Good morning, everyone. My name is Kadek Diva Sapitri, and today I will present about factors. So, factors are one of the fundamental concepts in the mathematics and physics because they help us describe quantities that have both magnitude and direction. In this presentation, we will discuss the definition of factor, different types of factors, factor notation, factor operation, and a real-life application of factor. So, let's begin. Okay, before we start, let's look at today's learning objective. By the end of this presentation, you should be able to explain the concept of factor, second, classify different types of factor, and third, apply basic factor operations such as addition, subtraction, and scalar multiplication. This objective will help us understand factors step by step. Okay, next. Before, we discuss, before discussing the formula, let's think about our daily activities. Whenever we move from the one place to other, drive a car, or throw a ball, we are actually dealing with factors. That's why we often say that factors open a window to the world, because they help us describe movement and direction more accurately. Now, let's learn what a factor actually is. Okay, next. So, what is a factor? A factor is quantity that has both magnitude and direction. Magnitude tells us how large the quantity is, while direction tells us where is it pointing. Okay, the next. So what is the factor? Okay, next. What is a factor? So a factor is a quantity that has both magnitude and direction. Magnitude tells us how large the quantity, while direction tells us where it is pointing. A a factor is usually represented by an arrow. The tail of the arrow represents the starting point and the head represents the ending point. Some common examples of factors are force, velocity, and displacement. Unlike factor quantities such as mass, temperature, and time, only have magnitude and are called scalar. The next, types of factor. Now, let's look at some different types of factor. The first type is negative factor. Negative factor has the same magnitude as the original factor but points in the opposite direction. The second type is zero factor. A zero factor has magnitude of zero, so it has no specific direction. It is represented by a single point on the coordinate plane. The third type is equivalent factor. Equivalent factor has the same magnitude and the same direction, even if they are located at different positions. Okay, next. Next is factor in a coordinate system. The factor can also be represented using coordinates. There are two common ways to write factor. The first is column factor, which is written vertical, and the second is row factor, which is written horizontally. Although the notification is different, both represent the same factor. The choice of notation depends on the context and mathematical convention being used. Okay, next is magnitude of a factor. Next, learn, let's learn how to find the magnitude of a factor. The magnitude represents the length of the factor. For a factor with coordinate xy, we use Pythagoras theorem to calculate its magnitude. For the example, if the vector is 3, 4, then its magnitude is the square root of 3 square plus 4 square, which equal the square root of 9 plus 16, or the square root of 25, which is 5. So magnitude of the vector 3, 4 is 5. Okay, next is vector addition. Now let's discuss vector addition. To add two vectors, we simply add their corresponding components. This means we add the x component together and then add the y component together. The result is new vector representing the combined displacement. Vector addition is commonly used to determine total movement or total force. Next is vector subtraction. Subtraction vector is familiar to addition. The only difference is that we subtract the corresponding component instead of adding them. Another way to think about vector subtraction is by adding the negative of a vector. This operation helps us determine the relative position or displacement between two objects. Next is scalar multiplication of vector A. Another important operation is scalar multiplication. A scalar is simply a real number. When a vector is multiplied by a scalar, every component of the vector is multiplied by that number. For the example, if we multiply the vector 3, 4 by 2, we obtain the new vector is 6, 8. So if the scalar is greater than 1, the vector becomes longer. If the scalar is between 0 and 1, the vector becomes shorter, and if the scalar is negative, the vector changes its direction. Next is contextual problem. Now let's look at a real-life example. So Gino walks 4 meters west and then 3 meters south. What is the shortest distance from Gino starting point to his final position? So these two movements from a right triangle using the Pythagoras theorem. The displacement is the square root of 4 squared plus 3 squared, which equal the square root of 16 plus 9, or the square root of 25, which is 5 meters. So therefore, the shortest distance between a general starting point and final position is 5 meters. This shortest distance is called resultant vector or displacement. Okay, now it's your turn to practice. This exercise will help you apply the concept we have learned today. The first equation asks you to calculate the magnitude of a vector. The second question requires you to determine the total displacement using vector addition. The third equation asks you to find the relative position of one runner with respect to other using vector subtraction. And finally, the fourth equation involves scalar multiplication by repeating the same movement several times. Try to solve the problem step by step using the vector operation we have discussed. Okay, this brings us to the end of this presentation. Today we learn that a vector is quantity that has both magnitude and direction. We also studied the different types of vector, vector notation, how to calculate the magnitude of a vector, how to perform basic vector operations such as addition, subtraction, and scalar multiplication. And finally, we saw how vector can be applied to solve real-life problems involving displacement. Thank you very much for your attention. I hope this presentation has helped you understand vector more clearly and see you in the next lesson and have a wonderful day. Thank you.